Bismillahirrahmanirrahim. I would like to start my presentation with the introduction. My name is Samidur Rahman. I'm currently working as a lecturer and an FIP coordinator of data science at AI, CS, and SE at QCIT, City Ministry of Science and Information Technology, Peshawar, from 2023. Before that, I was working as a lecturer at Beacon House, named as Concordia College, Peshawar, from January 2022 to November 2023. Regarding my education, I am currently a candidate of a PhD enrolled in from I'm Sciences, currently doing my PhD from I'm Sciences. And before that, I completed my MS in Computer Science from same institute, I'm Sciences, Peshawar, with the GPA of 3.4, completed in September 2023. And I have completed my BS Software Engineering from I'm Sciences, Peshawar campus, completed in September 2019. This was a brief introduction about my experience and education. So, today's our topic is, which I would like to present is graph data structures. So we will look about what is the convention definition of graph, then I would suggest the content definition of a graph, components involved in graph, types of graph, representation of a graph, how we can represent the graph, the comparison between graph and trees, then followed by the advantages and disadvantages of a graph. Starting my presentation, what is graph data structure? So, starting the graph is a non-linear data structure. Now, the term non-linear, what does the term non-linear mean? Non-linear means the data elements are not representable in a straight line or a linear form like arrays or linked lists. It can be represented as a hierarchical form. So, graph is a non-linear data structure. As a hierarchical, it consists of nodes and edges. So, consists from vertices, which is also known as node, and edges. Now, what is node and what is edges? We will look into it in the further coming slides. The vertices are sometimes also referred as the nodes, and the edges are lines or arcs that connect any two nodes. So, in the simple term, it means that there is a data point which is called nodes, and between two nodes there is a connection, there is a path, there is a representation, there is a relationship that can be represented as edges. So edges, by definition, we can say that edges are the representation or the relationship between two nodes, and nodes are the endpoint or a data point. So with this, we can conclude that a graph is composed of set of vertices that could be also known as node and the set of edges which is represented as E. So the graph is denoted by G of V comma E. That is the simplest and the smallest way to represent a graph in a equation manner, you can say that. So the key terminologies in this is vertices, edges, adjacency, and weight. So vertices represent the entity in the graph, as I earlier mentioned. The endpoint or the data points in a graph is known as vertices or nodes. Edges represents the connection or a relationship between two vertices. For example, if as I am a lecturer and I have a relationship with my students. So student is one node, and the teacher as I am the second node. The connection between them is a teacher teaches the course to that specific students. So edges represent the connection and the relationship between that two nodes. So we can also stimulate the real world scenarios with the help of graphs. Adjacency, when two vertices or two nodes are adjacent, if they are connected by an edges. So, connected by an edges means, for example, we can consider it as this graph. Okay, this is one node, this second node. 1, 2, 5, 4, and 3 represents the nodes, the endpoint. The relationship between them is called edges, as mentioned. The adjacent vertex means this node is connected with directly connected with any other node. So 5 is adjacent to that node, 2 is adjacent to that node, 3 is adjacent to that node. As this is a directed graph, so 4 is not directly connected to the 3. Vice versa, 3 is connected because the arrow is on this side. So this is the whole scenario: nodes, edges, vertices, and adjacent vertices or nodes. So the final term will be the weighted. What would be the weight? The value associated with that edges is known as weighted. The value, cost, distance, etc. associated with an edge is weighted graph. So if we have a graph and the edges have some values like 2, 4, 3, any other values, so we can say that yes, this is a weighted graph. Let's for example, we have maps. Yes, in maps we have how the Google map and other maps are uh, counting that distance. So with the help of that weighted graph, it can calculate the total distance, that what path should be considered as the shortest path. So coming towards the type of a graph, for example, the first one is null graph. A graph, these two are graphs, null graph and trivial graph. Null graph are those graphs in which no edges are present. It means that no relationship, no association of nodes with each other is present in that graph. So by the definition, it is clear that a graph is known as a null graph if there is no edge in the graph, as you can show, you can see in this diagram also. One, 1, 3, 4, 5. So the next one is trivial graph. A graph only have a single vertex, means a graph having a single node. It is also known as the. It is also be considered and also known as the smallest graph. Yes, it is. It can be the number of edges can be by itself. We can say loops. Loop is also known as the trivial graph. So there is a key difference between these two. Null graph having zero number of edges, trivial graph have at least one node or one vertex, a single vertex. Next one is undirected and directed graph. So it is very simple. Undirected graph, those graphs which have no direction associated with that edges, and undirected in undirected graph. In directed graph, there is a direction associated with that specific edges. By definition, it is clear that a graph in which edges do not have any direction, that is, the node are unordered pairs. You can traverse it from either this side or this side. It is unordered pair. There is no order specifically mentioned in this graph. While in other hand, directed graph, we are restricted or to have the traversal in a specific direction. A graph in which edge has a direction, that is, the nodes are ordered pair in the definition of every edge. For example, 3, from that node we can only access this one. We cannot traverse it on the anti-clockwise 3 to 5, then 4, then 1. While in undirected graph, the ball is in our court. Either we traverse it from 3145 or 3541. Next one is a connected and disconnected graph. So as with the help of diagram, it is clear that connected graph are those graph. in which we can traverse or we can reach every other node from any specific node. For example, if we consider this example, we can access 3 from that one node, 1, 4, 5, 3. We can access 3 to 3. We can access 1 from 3 also, 3, 5, 4, 1. But in disconnected graph, at least one node is not reachable. While if, for example, if we want to traverse that graph, so from one only four will be accessible. These two are disconnected. Five will be accessible from three. Three will be accessible only from five. Four will be accessible from one, and one will be accessible from the four only. So these two are not connected. That's why this is called disconnected graph. So by definition, it is clear that at least one node cannot be accessible or not be reachable from any node from which we are going to traverse that graph. The next one is cycle graph and cyclic graph. Cycle graph are those graph in which the loop, or we can say that every nodes are connected, or the other minimum requirement is value of degree of each vertex is. Now, what is mean by degree of each vertex? Degree of each vertex means the edges associated with that specific node. So, as we can see that in cycle graph, every node have a degree of 2. Means every node, every vertex have two edges. 3 have this one and this one. 1 have this one. 4 have this one and this one, and 5 have this one and this one. Though every node, every vertices have a two degree of two vertices. And on the other hand, cyclic graph are those contain at least one cycle is known as cyclic graph. Consider this graph where we have 1, 4, 3, 5. So 1, 4, 3 is considered to be a cycle, but the 5 1 is not be considered in the cycle path. So this will be called a cyclic graph, as it is not a cycle graph because 5 is not even connected. 5 the minimum degree of of 5 is 1, but it is a cyclic graph. We can say that because 1, 4, 3 have maximum have a cycle graph. So the next one is weighted, as I earlier mentioned that and explained the what is mean by weight. So the graph in which the weight, the number, the cost, the distance is associated with that specific edges is known as a weighted graph. So by definition is we can say that a graph in which the edges are already specified with a suitable weight, already means weight are assigned to that specific edge, is known as a weighted graph. Weighted graph can be further classified as directed weighted graph and undirected weighted graph. Weighted graph can be in both directed or undirected, both considered to be a both graphs. The next section is representation of graph in data structure. Okay. We have on two main common representation of a graph. Number one is adjacency matrix. Number two is adjacency list. There is these two are the ways to represent the graph in the graphs. Right? So the first one is a matrix. As we know that matrix considered to be a rows and column 2D matrix, uh, we can represent the graph in terms of matrix. So in this method, the graph is stored in the form of 2D matrix where rows and the columns denote vertices. Each entries in the matrix represent the weight of the edge between those vertices. For example, consider this as a graph 1, 2, 0, and 3. These are the nodes, and these are the edges. So to represent this in a matrix, we write the number of or the name or the edges, sorry, or the vertices on the rows and the column portion. Now, in that matrix we the number represent the weight associated with the edges. So zero is is there any path or edge between 0 to 0? In on the other hand, it means that is there any loop? No. So we consider as a zero. From 0 to 1, yes, there is an edge. So 0 to 1, 1 is present. From 0 to 2, yes, 0 to 2, 1. 1 means yes and 0 means no. 0 to 3, no directly association, no direct representation, no direct link from 0 to 3. So we wrote as a 3. So from same as for 1, 1 to 0, yes, 1 to 2, yes, 1 to 1, there is no loop, and 1 to 3 is no direction. So as we can see that or assume that the diagonal is 0 means there is no loop. 0 itself is not connected, 1 itself not connected, 2 itself not connected, 3 itself not connected. So we can conclude that there is no loop in this graph. The same is for 2 from 2 to 0, yes, 2 to 1, yes, 2 to 3, yes, 2 to 2 itself is 0. Next one is the adjacency list. So in this approach, we represent in this approach we represent the graph in the form of linked list. So we have a pointer which points to edges connected to that vertices. For example, consider this as a 0 to 1 and 0 to 2. We have only possible ways 0 to 1 and 0 to 2. From 1 to 0, 1 to 2, 1 to 0, 1 to 2. From 2, 0, 1 and 3, 0, 1 and 3. From 3, we have only direct access to only 2. From 3 to 2. So we can represent the adjacency list, the graph in the form of adjacency list. So these two are the most common and way of representation of a graph. Now coming towards the differentiation between the tree and the graph. So as we know that tree is in a hierarchical structure and graph is a network-like structure. So there are some key points which can differ the graph and the trees in itself. So in trees, starting with the trees, in trees only one path edges between two nodes. For the more clarity, I will show the diagram. In trees, there is only one edge between two nodes or two vertices. But in graph, we have multiple paths, multiple edges between two nodes. For example, we can have A, B, C. A is connected to itself A is connected to B, A is connected to C. So we have multiple paths. There is no restrictions between the edges of the two vertices. As tree has a root node and graph have no root node found in graph. Tree has a root node, but in graph we can traverse from any point, either from this one, this one, this one, this one, or this one. Do not have loops. It is obvious that trees have no loops, no repetition, but in graph we can have the loop at this point, at this point, at this point, this point, this point, wherever we want to. Number 4 point is number of in trees having n minus 1 edges. N is the number of nodes. Means if it is considered that its number of nodes is 1, 2, 3, 4, 5, 6, 7. 7 number of nodes and the number of edges would be n minus 1. 1, 2, 3, 4, 5, 6. So it is clear that from that definition, it is very satisfactory that yes, the number of edges must be minus 1 from the number of nodes. No number of edges not defined, as I earlier mentioned that there can be a loop, there can be a multiple association from one path, one node to another node. The number 5 point is in trees there is a hierarchical structure as we consider this parent, child, subchild, uh, and so on. But in graph there is a network-like structure that is connected to this one, this one, this one. There is no root node in this. So, advantages of a graph, the last section is advantages and disadvantages. Starting from the advantages, the main advantage of a graph data structure is to represent a wide range of relationship. Is for example, in real world example, we have on Facebook and LinkedIn and Twitter, Instagram. There is multi other application or scenarios in which the wide range of relationships are present. So, to represent that relationship in terms of graph is very suitable. And the other thing is it has no restriction like previous data structure like trees have loops and have the hierarchical arrays, linked list, and because arrays and linked lists are linear data structure and graphs are non-linear data structure. The other example is any real world problem where the certain set of items and relationship between them can be easily modeled. As previously I explained that the scenario in which the nodes represent the users and the relationship between them represent the edges. So in that scenario where the relationship and the persons or any customer is there, so we can easily model that as a graph. And a standard graph algorithm that breadth first search, depth first search, spanning tree, shortest path, topological sorting, and strongly connected. Graph data structure can be used to represent complex data structure in a simple and intuitive way, making them easier to understand and analyze. So, the disadvantage of a data structure is non-technical person cannot understand, or the user who is not familiar with the graph theory or the related algorithm cannot understand, or it's hard to be understand that graphs. Because in graph there are multiple association rules, the edges, then vertices, and mm, then other traversal rules. So it is very hard for the non-technical person to, to understand that graph easily. The second disadvantage is the graph data structure can be difficult to visualize and analyze, especially for very large and complex graphs. So, if there, let's suppose, there is a scenario where the graph data structure is implemented, and there are multiple user, multiple rules association, multiple connection between them, the messy network. For example, there is a very messy network. So, in that scenario, the understanding and the visualization of or analyzation of that graph would be very difficult. Uh, Thank you so much. Thank you so much.